Throughout my career, I've been fascinated by the really deep questions, things like the nature of the laws of physics, the origin of the universe, the origin of life, the origin of cancer. All of these things are fundamental questions. And for me, the appeal of thinking about them is to try to understand how the world works. From the earliest age I can remember, I was fascinated by the sky. I grew up in North London in the immediate period after the Second World War. I found that just by looking up, I could enter a wonderland of weird objects and strange phenomena. And so already by the age of about 11 or 12, I was resolved that I was going to go into a subject like physics and astronomy. And so that's been my path.
Where they said the star appeared, what you see is this. It's a ragged cloud of gas.
I think it's important to be honest. Science is worth doing for its own sake. Science is the best way we have of uncovering what is going on in the universe, what is going on around us, how nature works. One of the big problems of trying to find life elsewhere in the universe is we have no idea whether there's any out there at all, because we have no idea how life started. If we knew how it began, we could try to estimate the odds of it happening a second time. What is life? What is the distinguishing characteristic of a living system from a non-living system? Most life is microbial, and the microbial realm is immense, but we've only just scratched the surface. There are millions and millions and millions of species of microbes that have never been studied. And the question arises, in that microbial realm, could there be some that are not our form of life, but not as we know it, a radically alternative form of life on a separate tree of life with a separate origin? We call this life 2.0. And you can't tell by looking what makes a microbe tick. You've got to dig into its biochemical innards. And so the problem is, even under a microscope, life 2.0 may look just like life as we know it. You can't tell, and you have to investigate its internal chemistry. So one of the first things I did here at the Beyond Centre was run a workshop on searching for a second sample of life on Earth. What would we do? What would that strategy be? How would we go about it? How would we find this life 2.0? And resulting from that, I think we've initiated a research program where there is a possibility, if it's out there, that we could find a second sample of life here on Earth within a decade or so. It shouldn't be that hard. And if it's the case that life has happened twice on Earth, and may have happened 100 times, but twice is enough. If we just find one single representative of an alternative form of life right here, right under our noses, intermingled with known life, then we could say with confidence life must be easy to make, and therefore it's probably all around the universe. But if there's only one form of life on Earth, it's entirely possible it was a freak, unique event. Happened only once, happened here, we're it, the rest of the universe is dead. That's entirely possible. We're trying to uncover how the universe around us works, the underlying laws of nature, the hidden subtexts of nature, determining what is our place in nature, how do we emerge from nature, and what does the future hold in this magnificent universe of ours. So this is a quest which is driven just as much from the heart as from the head. And if we're not passionate human beings, if we don't really believe that we live in a wonderful universe and that life itself is wonderful, then I'm not sure that that's a society I would want to live in.